Today we're going to be finding the greatest common factor using two possible strategies, using factor lists and prime factorization. First, we need to talk about what common factors are before we get into greatest common factor. Common factors are factors that are shared by two or more numbers. And the greatest common factor is the greatest of the common factors of two or more numbers. There are two possible strategies we're going to be learning. The first, as I said before, is making a list. The second is to find the prime factorization, and we're going to go through two examples side by side so you understand how each one of them can help you find the greatest common factors of two numbers. The first strategy we're going to go over is to make a list, and we're going to be finding the common factors. We want to find the greatest common factor of 18 and 30. And how I usually make my list of factors is with a little T-chart. And I'm going to first list out my factors of 18. First I have 1 times 18. I have 2 times 9. And I have 3 times 6. So in case you're wondering how I made the list like that, I started with my 1 times table, 1 times 18, then 2 times 9, then 3 times 6, and worked from out to in. Now we're going to do 30. First I have 1 times 30, and then I know that 2 times 15 equals 30. Then I have 3 times 10. And finally, I have 5 times 6. So we have our list of factors, and the reason I like doing this is because you have your factors ordered from least to greatest this way, and it helps you see what your greatest common factors actually are. Another way you can do it if you don't understand why we're making the list like this is like this. Same setup. And you can just write it like this. 1 times 18, 2 times 9, and 3 times 6. And then we have our 1 times 30, 2 times 15, 3 times 10, and finally we have our 5 times 6. So either way works. You can do whatever way makes sense to you, because as you're going to see, we're still going to get the same answer. So if I look at the factors they share 1, 2, 3, and 6. But since we are finding the GCF, or the greatest common factor, we want the greatest number that they share. They share 1, 2, 3, and 6. 6 is the largest. So 6 is going to be our greatest common factor. And in this, if you list them out like we have down here, you can see what is the same. You have your 1, you have your 2, you have your 3, and you have your 6, but they're not in a nice organized greatest or least to greatest list like this up here. So we still see that they share 1, 2, 3, and 6, and 6 is still the largest. So no matter which way, we'll still get the greatest common factor of 18 and 30 equals 6. We're going to do the same two numbers with prime factorization as our strategy to find the greatest common factor. So again, we're still finding the GCF, which is the greatest factor that two numbers have in common. And we're still going to use 18 and 30. So we're going to get our prime factors of 18 and 30 by making factor trees, like we learned previously. So we can break down 18 into 3 times 6. 3 is prime, so I'm done with that, but 6 can break down into 2 times 3. And 2 and 3 are both prime, so we're going to circle those. 30 can be broken into 3 times 10. 3 is prime, but 10 can be broken down into 5 times 2. 5 is prime and 2 is prime. So the prime factorization of 18, and we're going to use a t-chart similar to what we used when we made a list to list out our prime factors. The prime factors of 18 are 2 times 3 times 3. And the prime factors of 30 are 2 times 3 times 5. The prime factors that 18 and 30 share are 2 times 3. So what you do is you take the two prime factors that they share, which are 2 and 3, and multiply them together. The answer of, or the product of your prime factors that they share, your common prime factors, is 6. That will be your GCF. So again, first we find the prime factorization of the two numbers that we're looking at. Then we write out the prime factors and find out which ones they share. Multiply which ones they share, and that's your greatest common factor. So for 18 and 30, they shared 2 and 3. So we multiplied 2 times 3, and we got 6. So our GCF equals 6. The last thing we're going to do is do the two different strategies for another two sets of number, but we're going to do them side by side so you can see how they're related and how they look alike. So the numbers we're going to find the GCF of are 36 and 45. So we're finding the GCF of 36 and 45. So if we make a list, we're going to go ahead and make our t-chart that we made on our first example. And this is where we list out our factors of 36 and 45. So for 36, we have 1 times 36. I know that 2 times 18 equals 36. 3 times 12. 4 times 9. All of those factors, or all of those problems, equal 36. And remember, another way I can write them out. We can list them from least to greatest by working from the outside to the inside. We have 1 times 36, 2 times 18, 3 times 12, we have 4 times 9, and we also forgot one at the top, we have 6 times 6. And if you have a number that's multiplied by itself and you're making a list like we're making down here at the bottom, you only have to write that number once. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, 9, 12, 18, and 36 for the factors of 36. Now let's do 45. We'll list our multiplication problems first. We have 1 times 45. 45 is not a multiple of 2 because it doesn't end in an even number, but it is a multiple of 3, so it's 3 and times 15. We also have 5 times 9, and that's actually it for 45. So let's go ahead and make our list down here. We have 1 times 45, 3 times 15, and 5 times 9. So now we can look at our list of factors. The ones that they share, or the ones that they have in common, are 1, 3, and 9. Those are the only factors that they have in common. And the greatest factor that they have in common is 9. So we're going to say the GCF equals 9. Now we're going to find the GCF of those numbers using prime factorization. So we're going to go ahead and make our factor trees of 36 and 45. 36 can be broken down into 12 times 3. And 3 is prime, but 12 can be broken into 3 times 4. 3 is prime, but 4 can be broken down into 2 times 2. And those are now both prime numbers. So if we list out our prime factorization of 36, that problem will be 2 times 2 times 3 times 3. 2 times 2 times 3 times 3. And then let's do 45. 45 can be broken up into 3 times 15. 3 is prime, but 15 can be broken up into 3 times 5. And again, 3 is prime and 5 is prime. So our prime factorization listed out is 3 times 3 times 5. Now we're going to look at the numbers that they share. They don't share the 2's, they don't share the 3's, but they share this set of 3's and they share this set of 3's. So since they share a 3 and another 3, the problem for the GCF would be 3 times 3, which would be 9. So the GCF, or greatest common factor, from finding the prime factorization is 3 times 3, which is 9. So you notice no matter which way we do it, we still get the same answer. Making a list got us the greatest common factor of 9, and finding the prime factorization got us the greatest common factor of 9. Now I want you to try these 3 problems on your own for independent practice. Use the back of your paper to solve them by either using prime factorization or making a list of your factors. For the first one, find the greatest common factor of 11 and 44. Number 2, find the greatest common factor of 28 and 40. And number 3, find the greatest common factor of 24 and 60.